Whoops. Okay. So I've solved for my x component, right? 8.64, my total y component. And now I want to move to the next part of the problem, which asks me to find the total magnitude and direction of force on Q3. So remember, I found my total force in the x direction, which is this. I found my y component, which is this. So if I want to look at these forces, I need to see what they look like added together, because what I want to find is what sum of forces in x direction plus sum of forces in y direction is to give me the total net force. So net force equals sum of forces in x plus sum of forces in y. This is in 2 dimensions, so this tells me how to draw the diagram, right? The vector diagram, which I've done here. So notice, since it's negative, I know y points downwards. I add that head to tail to my x direction, and it shows me how to draw my net force. So I need to solve for the magnitude, but I also need to talk about the direction. In order to do that, I want to find the angle below the horizontal. So we've got 2 jobs. So first we're going to find, for a 90-degree triangle, we know that a squared plus b squared equals c squared. C is always your hypotenuse, right? So the sum of forces in the y direction squared is 8.64 times 10 to the negative 5th squared, plus the sum of forces in the y direction, negative 5.52 times 10 to the negative 5th squared, equals the total net force that we're solving for squared. And that's why I've taken the square root of both sides to find the total sum of forces, which is 1.03 times 10 to the negative 4th. And finally, I want to find that direction. So in order to describe the direction, I need the angle below the horizontal. And I know that angle is equal to this angle because of alternate interior angles are always equal. So if I want to find this angle, I can use tangent because I have opposite and adjacent. And so tangent of theta has to equal the sum of forces in the y over the sum of forces of the x, because the sum of forces in the y is the opposite side, sum of forces in the x is the adjacent side to the angle. So given that, I'm going to use inverse tangent to find my actual theta. So inverse tangent equals, and then again, I just put in the magnitude of sum of forces in y over the magnitude of the sum of forces in x, and plug it into my calculator, and I get that it is 32.6 degrees below the horizontal, right? And just to see again, there's part A.